Now here I added usereducer instead of useState, not because we replaced so many state things with it. Actually, we only replaced this one user ingredient state. But because we have multiple ways of changing that state, and some of these ways depend on the previous state. And whilst the previous approach there, of course, also worked fine, using a reducer often is cleaner, because you have all your updating logic in one place, in the reducer, and then you just dispatch these actions, which is a very clear and easy to understand flow for how you manage your data. So whenever you have more complex state that can change in different ways, instead of just, let's say, setting a boolean from true to false, but like here where we can add ingredients or remove ingredients, whenever you have such a state that is a bit more complex and that might also depend on previous state, then you should strongly consider using a reducer to have a cleaner logic, to have all in one place, basically. And ultimately, it's of course up to your personal preference, though. Another scenario where using usereducer could make sense is if you have multiple connected states. Like here, is loading an error? They're both related to us sending HTTP requests, and whilst we manage them independently, they're kind of related. Now, you can, of course, manage it like this, but also here, often a reducer makes your code easier to reason about, easier to understand. So I'll add another reducer, again, outside of my component. Doesn't have to be outside. You could move it in there, for example, if you use props in your reducer, but if you don't need to, put it outside of the component to avoid unnecessary recreations of the reducer. So here, I'll name this HTTP reducer maybe. Again, get my HTTP state and my action. And just as before, you can name these arguments whatever you want, of course, but this will be your old state basically, and that's the action you're getting. And just as before, we can switch the action type, because there will be different actions we'll dispatch. And now let's think about which actions might we have when we work with HTTP requests. Well, if we have a look at our code, then we always start by sending the request, right? We start off by sending a request. So sending a request probably is one action. Another action we then have is when the response is there, in this then case, or when we have an error, in this catch case. So we have three possible states here that make sense. Three different cases, I should say. So the first case is send, or send request, or whatever you want to name it. I'll just name it send. The second case is response. So the response is there. Again, you can name this whatever you want. And an error case. And just as before, a default case where I, however, will only throw a new error. Should not be reached. Because we're the ones dispatching these actions, we should of course make sure we only dispatch actions with these identifiers. If we ever see this error, then we dispatched some action we're not handling. And then we should either fix a typo we have or add a case for that action. Now what happens if we send a request? Now it's important to understand that here we'll not send the request itself. We're doing that down there. Here I just want to manage the state that is related to that request being sent that influences our UI. So the state there is basically whether we show a loading spinner or whether we show an error. That's essentially the state I want to manage related to that request. So here, when we initialize this with usereducer and we point at our HTTP reducer, then the initial state could be an object where we have two fields, and that is loading, which is false initially, and error, which is null initially. Here I'm using an object because a reducer could also just manage a single string, but here I want to have multiple connected fields, and therefore I have an object to connect them. Now when we send a request, we want to set loading to true, and the error probably to null, because we have no error yet if we just send the request. And this is the new state we'll return. Of course, it should match the signature of our general state, like the initial state we're managing here. And that is the case here. We have a loading property and we have an error property. If we got a response, then I'll set loading to false and I'll set error to null, or actually I just don't want to change the error. A common pattern therefore is that you actually set the property you want to set, but before you do that, you simply take your existing state and use the spread operator to pull all key value pairs out of it merge it with this new object, which will be returned as your new state, so that you don't lose anything from the old state. And whatever you set thereafter will override any properties of the same name that were pulled out of the old state. So if the old state, we have a loading property in there, we're pulling that out and adding it to the object, but since we also define it here, we then override that value with that new value. Other properties, which we don't override here, will simply be kept in this new object. If we have an error, then I want to set loading to false, because we're still not loading anymore, even if we have an error, and set the error to action error. So we probably should get it here, or error data, or whatever you want to have here. You're the one writing the code, you can define what you expect on your actions. Here I'm not using the spread trick or the spread approach, because here I'm setting both properties which my state here has. So no need to spread existing properties, I would override all of them anyways. So that's the HTTP reducer. usereducer therefore returns our HTTP state, or whatever you want to name it. I'll name it HTTP state. It's the same name as I have up there. So to avoid confusion, you don't have to change any of the two because they're in different scopes. But to avoid confusion, I'll name this priv HTTP or cur HTTP state, because it's the current state before the update up there. And here it's just HTTP state. And again, we get dispatch. Now I already have a dispatch variable though, so I'll rename this to dispatch HTTP so that we have no name clash here. And here we need to rename it because they're in the same scope, hence we can't use the same name twice. So now we can get rid of these two use state statements and now fix all these errors we're getting. For example, here for loading. In the end, what's happening here is that I want to dispatch an HTTP action, and that action is of type send. So that's the identifier I defined here. And that will then automatically set these state values. We don't need to pass any extra data to that action because that action doesn't need any external data to work. So we send a request here. Now, when we got a response, I'll send the response request here. Down there in remove ingredient handler, again, it's the send request which I'm sending. And then here, if we got a response, it's the response request. Only here, if we have an error, well then I want to dispatch my error action, and that's the only action here that then takes an extra argument, because in our reducer we're accessing error data on the action to get the error. Actually, I'll rename this to error message because I want to get the message and store that in error, so that error always is a message. And then down there I pass error message as a key, and that is error.message, or again, a message of your choice, like something went wrong. Now in clear error, there we actually need to dispatch an action we don't have yet. So let's register a new case, and that is clear maybe, where I return my current HTTP state, but I set error to null, because that's what we're doing here. We're keeping all the old state in this new state object we're returning, but we're setting error to null. So now we can dispatch this clear action here. So dispatch HTTP with an object where the type is set to clear, so that this clearing is happening. Well, and then here, instead of error, we access HTTP state. Remember that HTTP state is now what we're extracting from the result of usereducer here. So that is in the end this object with loading and error, which we're constantly updating. So we got our HTTP state, which might contain an error. HTTP state error is what I output here, and HTTP state error also is what we need to check here. And then here it's HTTP state loading. With that, if we save this should again work correctly. If I add a new item here, we see the spinner, so loading works, we see that here. And now if we add an error again, for removing, let's say, by again removing that S from JSON, if I now click here, we see that, we see the error modal, we can close it. So that is now all working. Let me re-add the S. With that, we're using a reducer for this too. Here, we're doing it because we have multiple connected pieces of state, which we now can manage in one place and still make sure that we always get the old state, that we update everything correctly, and that again, we take some logic out of our component here and move it into the reducer functions so that we have cleaner code where we have a clearly defined flow of data and of where we change our data. Now we can also get rid of the use state import here in the ingredients.js file, because now we're managing all our state with usereducer, which is an alternative to use state if you got more complex state that relies on the old state, or if multiple state values work together and you want to manage them in one place and update them correctly.